Hello everyone, it's December 13th. Alright, let's see. I think it's going to be a hard one today. Yep, it is a hard one. Alright, we're going to follow the rules of... Oh, we've done this before. Doesn't matter, we follow the rules. If we cannot figure out a way in 15 minutes, we are going to check the hints. Alright, a long library corridor, line of seats, and decorative plants. You're given a zero-indexed string corridor of left end consisting of seat and plant. One room divider has already been installed to the left of index, so we have this black one, and another to the right, the two black ones. Additional room divider can be installed for each position between indices I-1 and I. Wait, hold a second. To the left of index 0 and to the right for additional room divider. So from basically to the left of 1 to n-1, at most one divider can be installed. Divide the corridor into non-overlapping sections where each section has exactly 2 seats with any number of plants. There may be multiple ways to perform the division. 2 ways are different if there is a position with a room divider installed in the first way but not in the second way. So basically we'll divide this SSPPSPS. We can divide it such that there are exactly, right? It says exactly 2 seats and any number of plants. Multiple ways to perform division to return the number of ways to divide the corridor since the number will be big. Well, so 2 seats, so we've got seat. This is definitely deterministic. Seat. So it's this. Well, but that's the first time we do it. And of course, I think we'll get a seat out, right? We have 4 seats and we have index. This is 0, 1, 4, and 6. And let me put them a little bit further apart. Right, these are 4. And we need to divide them such that there are exactly 4, or exactly 2 for each one. And if the number is not divisible by 2, then that's not possible, right? Then it's not possible. And if there's only 2, then there's only one way, like in this example, right? There's only one way. Do we have another example? This is a 0 way because we only have 1 seat. Okay. Yeah, so once we do this, we know exactly where to put it. So we'll put it here. There's no other way. And then we find how many gaps are in this. So we have 2 and 3, right? So basically, we can put 1 position, 2 position, 3. We'll have 3 position in this. So 4 minus 1, we have 3 position in this. And that's it. That's a 3. So basically, we will gather this, right? Well, this is the 0, but we can have plant to the left, which means it has to be, so the number of positions, like if we have this is not 1, let's say it was 2, 3, right? Now we basically have 0, 1, we have 2 plants here, and this one is deterministic. So how many ways can we do? We have basically 2 ways, right? We have, this is a position and this is a position, right? So because you don't do it to the left, you do it to 0. So basically the first one minus 0. And then this is 0, basically we have 0 position to the left. That's pretty much it, right? So you got the first one out. You compute how many possibilities to the left. That's your first one. Right, so the starting position, so the pre, right, the pre will start with 0, and then we go, find the first S, then we will do this minus this is the number of ways. That's the first one you will get in, right? And then we'll count the second one once it's divisible. Count the second one. Once it's divisible, I'll swap the pre to this, right? And then we count the next one, which is not divisible. So since it's not divisible, I will do this trick. Okay, so we can try. Have a rough idea. I think it'll work, but it needs to see if it passes. I mean, overall, if that is all this there is to this problem, it's actually not that hard. But I'm not sure if things will get harder. So get all the indices, right? Indices for the chairs, for the seats, right? Since we can only allow exactly 2 seats per partition, we can find out the number of positions where the I don't call it partition. This is a partition. Section and corridor. Okay, where the corridor, right? Number of position where the corridor can be inserted, and the result shall be the product of all those number of positions. So I think should be ON. So we'll have long rest equal to 1. Actually, no, that's not necessarily true, but that's how we're gonna start with. I'll have int. Let's just go long for everything. We have a pre will be 0, and what we're gonna do is int seat count, right? 0 for int I, 0 I smaller than corridor dot size I plus plus. If corridor I is equal to p, right? I'll continue. Otherwise, it's a seat, right? Then we'll do seat count plus plus, and then we say if seat count mod 2 is equal to 1. Okay, so if it's equal to 1, that's the start of a new one that we need to compute the number of positions, right? Number of positions with the previous. So we say res, let's also do long, I can actually do int mod 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can say res shall equal to res multiplied by something mod. What is this something? There's a number of ways. Int num positions, right? It shall be I minus pre, right? And now we say if num positions is larger than 0, because if it's 0, then we don't really do it. So we'll multiplied num positions, and then we do a mod. If it's equal to 0, that means there's no positions. There's no positions that we can put, but that will only happen at the very beginning because of the 0. We start with 0 if it's a 0. If we have 1, then we have at least 1 position, right? So yeah, so we do that, and that's good. So else, right? Else, if it's equal to 0, that means my pre need to be updated to the current, right? That means my pre need to be updated to the current. So yeah, blah blah blah. Once we're done, we're going to say if seat count smaller than 2, return 0. Otherwise, return res. I wonder if seat count equal to 2, what's going to happen? Well, if seat count is equal to 2, then We have this first as 1. Then I'll have whatever this, right? And then we have this. Yeah. Actually, that's not true. I think it shall be mod 2 is equal to 1. It's always going to be 0. Now, if it's equal to 2, then... But why is this only one way? Oh, why I cannot do this? Oh, we'll create any sections that does not have exactly 2 seats. Oh, be very careful here. Be very careful here. So that actually doesn't work. So you need to start from the first seat. Ah, okay, so this one doesn't work. So, so we go. First seat, second seat. Okay. Okay, so the pre doesn't start. So see how I do this, right? So if it's go to 1, then it has to be, so if it's not, then we'll update. So we have the pre. Right now, pre is here, and then we'll end. Right, we'll end, but we didn't do anything to the result. That's why result return is 1. And here, if position, if it's equal to 1, so we have, but it has to be larger than 1, right? It has to be not only number of positions. Actually, this actually doesn't really matter, right? This actually doesn't matter. So because the first thing we'll count must be after 2, right? It must be after 2. And if we are doing this after 2, then the position would definitely be larger than 0. So what we need to consider is, so this actually will always work, but this need to change. We say seat count need to larger than 2. If seat count is equal to 2, or seat count smaller than 2, there is no way you can install anything. So let's try this to see if it works. So far so good. Let's see if there's some edge cases that we hadn't foresee. Well, we have, oh, seat equal to 0. Alright, that is an oversight. I bet I was hit by the same thing last time. Alright, let's try it again. Yeah, this is quite simple. A very scary problem on the first look. I bet, oh my god, last time I did not got hit by this. That was a Java solution. I reset it to 0. So similar idea, but I forgot to check if C can be 0. Yeah. Okay, that's about it, right? That's a very simple stuff. If all difficult questions can be like this. Oh, I didn't even think about dynamic programming. Huh. I feel DP, on the other hand, is actually not as intuitive as. Oh my god. How much did they write? It's a previous start. I said a previous start is 0. I think that's why it's maybe wrong. Yeah, that was the consensus. All right, that's pretty much it. And we'll call it a day. I'll see you guys tomorrow.